Okay, so in this lesson, we're going to continue talking about properties of logarithms. Now, in the previous lesson, remember, each problem involved just one property, whether it was the product rule for logarithms, whether it was the quotient rule, or whether it was the power rule. In this lesson, almost all the problems will involve two or more properties that you're going to have to use. Okay, but remember the properties. So the first property talked about was the product rule for logarithms. So the product rule. And so basically it said that if you have the log of a product m times n and with some base b, then you can expand this. It can be expanded to a sum. So it will be the log of m plus the log of n, and each of those has base b. Okay, now remember we related this to the properties of exponents from a previous course. So the product rule, remember in the previous course, indicated that if you multiply like bases, you add exponents. And so remember, since a logarithm is an exponent, since I'm taking the log of a product, then I'm going to rewrite it as a sum of two logs. So it's a log of m plus a log of n with base b. And so the quotient rule, remember, said this, that the log of m divided by n with some base is going to equal the log of the numerator minus the log of the denominator. All right, so the log of a quotient is the difference of the two logs, the log of the numerator and the log of the denominator with base b. And the power rule said this, that the log base b of m raised to the n power, so the argument, if the argument's raised to the n power, then I can write this as a product. I can write this whole thing as the exponent times the product of the logarithm. So the log of m base b. All right, so basically you're taking the exponent and you're going to rewrite it as a product. Okay, and we saw in a previous lesson why this is true. So if you need to go back to the previous lesson to kind of review what we've discussed, then go ahead and do so. Okay, now the directions for this will be the same as the previous lesson. So it'll say use the properties of exponents, use the properties of logarithms. This should be logarithms. Use the properties of logarithms to expand each logarithmic expression as much as possible. Evaluate the logarithmic expression without using a calculator. So if possible, evaluate the log expressions without using a calculator. So if you can do this without a calculator, then do so. You'll see what we mean when we get to those situations. It's the same as the previous lesson, except this time you're going to involve two or more properties with each of these problems. So for example, number one, suppose we had the log of log base 6 of y to the 10th power times z squared. So the log base 6 of y to the 10th power times z squared. Okay, now if you look at the two properties, or the properties that you're going to use here, you can definitely see that you're going to involve the product rule because you have y to the 10th times z squared. You also notice that I'm going to involve the power rule because I have a power involved. In fact, other than one, I have a 10 and a 2, a power of 10 and a power of 2. But the question becomes, and you got to be careful, which one do I use first? So if you're not careful, if you don't really understand what's going on, you're going to use a power rule first by mistake. That's a mistake. You can't pull this 10 out in front, or you can't pull the 2 out in front. Okay? Because in order to use the power rule, the whole argument has to be raised to that power. So if you notice, is this whole thing raised to the 10th power? The answer is no. Is this whole argument raised to the 2nd power? The answer is no. Okay? In fact, this whole argument is raised to the 1st power. All right, so what you want to do first then is use the product rule. So the product rule has to be first. So according to the product rule, this becomes the log base 6 of y to the 10th plus the log base 6 of z squared. And now I can use the power rule on each of those. So I can pull this power out in front, and I can pull this 2 out in front. So this becomes 10 log base 6 of y plus 2 log base 6 of z. And that will be your answer. You cannot simplify anything without a calculator. Okay, number 2. All right, number 2, suppose we had this. Suppose we had the log base 7 of x to the 8th power divided by y to the 4th power. All right, suppose we had that. All right, well, in the previous problem, from our discussion, we're going to use we use the product rule, and we also use the power rule. So that in the same situation, or the same idea, we're going to use the quotient rule, and we're going to use the power rule. And again, you gotta be careful which one you use first. It doesn't matter. So if you notice, I cannot use the power rule first because this argument is being raised to the 1st power. It's not being raised to the 8th, and it's not being raised to the 4th. It's only being raised to the 1st. The only thing being raised to the 8th is x, and the only thing being raised to the 4th is y. So you got to use a quotient rule first. And so when you use a quotient rule, I'm going to say that's going to equal the log base 7 of x to the 8th minus the log base 7 of y to the 4th. And now I can use the power rule. And so when I use the power rule, I'm going to rewrite this as a product now. And so I get 8 log base 7 of x minus 4 log base 7 of y. Now it's very important as you write your answers that these bases are written as subscripts. So notice they're subscripts. All right, and notice that also that the arguments, if this were lined paper, that the argument would be on the same line as log, and then 7 would be listed as a subscript. And it's also important that you don't forget to list your base, because remember there's no base there. It's understood to be a 10. All right, so you got to have a base. Don't leave off your base. All right, number 3. Okay, in number 3, let's suppose we had this. Suppose we had log base 6 of, let's say, 36x to the 8th power. Log base 6 of 36x to the 8th power. Well, again, I'm going to use the product rule, and I'm also going to use the power rule. But I've got to use the product rule first because this whole argument is being raised to the 1st power. So I've got to use the product rule first. So according to the product rule, this becomes the log base 6 of 36 plus the log base 6 of x to the 8th. And now remember the directions. The direction says, if possible, evaluate logarithmic expressions without using a calculator. So in the previous lessons, you learned how to look at a log expression and see if you can simplify without using a calculator. Remember, a logarithm is nothing more than an exponent. So in your mind, if you look at this, in your mind you're asking yourself, what exponent is this? What exponent is this? In other words, 6 to what power? So rewrite this log equation as an exponential. That's what we did in the previous lessons. So if you don't remember this, you need to go back to those previous lessons. So 6 to what power is 36? Well, 6 squared is 36. So this is a 2, which means this is a 2. So don't leave your answer like this, because if you can simplify without using a calculator, then go ahead and do that. So 6 squared is 36. That's what you're saying. 6 squared is 36. All right, and so we get 2 plus, and then over here, I can, since that's an exponent, I can use the power rule, so I can rewrite this as 8 log base 6 of x. And so that's your answer. And number 4, suppose we had log base 5 of 125 x to the 3/8 power. So log base 5 of 125 x to the 3/8 power. Well, according to our properties, I'm going to use the product rule and I'm going to use the power rule. But again, I've got to use the product rule first since the outer exponent is a 1. Okay, so remember the whole thing here is not being raised to the 2/3 power, only this x. 125 is not. This whole thing is being raised to the first power. So I've got to use the product rule first. So according to the product rule, this becomes the log base 5 of 125 plus the log base 5 of x to the 3/8. All right, now, according to what we just talked about, can I simplify this log expression? In other words, 5 to what power is 125? Is that possible to do without using a calculator? And the answer is yes. 5 times 5 is 25, and 25 times 5 is 125. So this is really 3. So remember what we did in our mind, we said this. Log base 5 of 125. So I want to know what exponent is that equal to. So what is this exponent? So we convert that to an exponential. So 5 to what power is 125, the argument. So 5 cubed is 125. So this expression right here is just 3. Now, I can use a power rule here. So pull that in front, and that becomes plus 3/8 times the log base 5 of x. Number 5. Okay, and before we do number 5, let's kind of review something else from a previous course, and that is writing radical, writing radicals as rational exponents. Okay, writing radicals as rational exponents. So in other words, in a previous course, you learned this. You learned that if you have x to the b divided by, let's do a divided by b. A divided by b, x raised to the a divided by b, then see how you have this base and it's raised to a fraction? Then I can rewrite this as a radical. You can write as a radical. The radical would be this. The denominator is your index, so that's b right here. And your radicand is this base right here, and it's being raised to the numerator power, so it's being raised to the a power. So again, remember what we just did. So if you have a base raised to a fraction, and you can write this as a radical, the index here is just your denominator, and your power, your exponent of the variable that's underneath the radical that's in the radicand, is your numerator. Okay, and so we can go backwards even. So if we had, let's say, the b root of x to the a, then I can write this as x raised to a fractional power, rational exponent. It's a divided by b. So it's your numerator divided by your index. I'm sorry, your exponent divided by your index. All right, so when we do the next one, we're going to use this idea here. So let's look at this then. Let's suppose we had the log base, let's say 7 of in the numerator we have the cube root of x, and in the denominator I'm going to have 49. So that's what I have. So I have a log base 7 of the cube root of x divided by 49. Okay, well, right away you probably would have in your mind thought, well, I'm going to use a quotient rule. And you're right, you're going to use a quotient rule. So let's go ahead and do that first if you want to. So that's a log base 7 of the cube root of x minus the log base 7 of 49. All right, so definitely that would be the first thing you would do. Nothing wrong with that. But we got to simplify each radical if possible. For example, if you look at this, without using a calculator, can you simplify this? 7 to what power is 49? Is that possible to do without a calculator? And the answer is yes. 7 squared is 49, so this is 2. Remember what we did? We said this. We said the log base 7 of 49 equals what exponent? Well, we changed this whole log equation to an exponential, so that becomes 7 to what power is the argument 49, and the answer is 2. So that's 2 here. So we'll be subtracting 2. But what you got to do now is think, can I use any other properties of logarithms? And the answer is yes. I can use the power rule. What I got to remember, though, is I have the cube root of x. So I have the cube root of x here. And so according to what we just talked about, I can write the cube root of x as x to a fractional power. And so the fractional power would be, remember, you're going to have a fraction, and so your index is your denominator. Now your question is, what's going to be the numerator? Well, remember, if you look at this, this is x2, there's no exponent there, so it's to be a 1. So that's a 1 right here, and so we get 1/3. So the cube root of x is x to the 1/3. And so what I'm going to do now is I'm going to rewrite just this little part for right now as log base 7 of x to the 1/3, and then I have minus 2. And now I can recognize that I'm going to use the power rule. And so I'm going to take this power and rewrite it in front, and so I get 1/3 times the log base 7 of x minus 2. And so that would be your answer. Okay, so a couple of things you have to use from previous courses in order to complete this problem successfully. All right, now let's look at this. So this is number 6. So number 6, suppose you had log base b, and let's say my numerator is x to the 8th power, y to the 9th power, divided by z to the 5th power. Okay, suppose I had that. All right, well, again, ask yourself, what properties will I use here? Well, if you look at this, you're definitely going to use a quotient rule because you see a fraction here. You're taking the log of a fraction. And in each of those denominators, numerator and denominator, you have some exponents. So you know you're going to use the power rule. But then if you notice the numerator is a product. It's x to the 8th times y to the 9th. So you're also going to use the product rule. So in this problem, you're going to use all three. You can use all three. Now, the question is, which one do I do first? Do I do the quotient rule first? Do I do the product rule first? Or do I do the power rule first? Well, first of all, let's look at the power rule. The whole thing is being raised to the first. So you're definitely going to use the power rule first. You will not, because you can't just take an 8 out in front. The only way you can do that is if this whole thing's raised to the 8th. You can't take a 9 out in front. The only way you can do that is if this whole thing's raised to the 9th, and it's not. It's only this y, and so on. So if you look at this whole thing's raised to the first. So you're done with, for right now, with regards to asking yourself, do I need to use the power rule first? And the answer is no, you don't. So then it leaves you with the quotient rule and the product rule. Well, if you look at this, the power rule only applies to the numerator. So you want to do that towards the end. So what you want to do first is do the quotient rule first. So you want to split that part up first. So in other words, you're going to say log base b of the numerator minus log base b of the denominator. And now notice this part. I'm taking the log of a product. So now I'm going to use the product rule. So I use the quotient rule first, and now I'm going to use the power rule next. So I'm going to have log base b of x to the 9th plus the log base b of y to the 9th, that should be 8 right here, minus the log base b of z to the fifth. Okay? Okay, so I use the quotient rule first, got this difference. And then for this first term right here, I used the product rule and got this sum. All right, so I have three terms now. So if you look at this, can I use any other properties to help me to expand this? So you got to use as many of these properties as possible. So don't leave your answer. Do not leave the answer like this, because it's not supposed to be left like this. What you're supposed to notice is that in each one of these, the argument is being raised to a power. The argument is being raised to a power. The argument is being raised to a power. So you want to use the power rule. So this becomes, so you can take the exponent and you're going to rise a product. So that becomes 8 log base b of x plus, and then do the same thing here, 9 log base b of y, and then minus, and then do the same thing here, 5 log base b of z. And so that would be your answer. You can't simplify anything. You can't use a calculator with anything. You cannot do any of these without a calculator. So b to the y power is x. Well, first of all, that's not a number. X is not a number. It's a variable. So you can't simplify any of these. So you're done. That's the answer. All right, now be careful with the next one. So remember how in this one the product rule, the product was in the numerator? Well, what happens if it's in the denominator? So let's look at this. Log of, let's say we had x squared divided by y squared z. Let's suppose we had that. So log of x squared divided by y squared z. Now remember, you see there's no base there, but remember that's understood to be a 10. So this is a common logarithm. So a logarithm of base 10 is called a common logarithm. So I'm dealing with a common logarithm here. Okay, so just as our discussion before, you're going to use the quotient rule, you're going to use the product rule, and you're going to use the power rule. And just as our discussion before, you're going to do the quotient rule first. Always do the quotient rule first. So that becomes log of x squared minus the log of the denominator. So log of the numerator minus the log of the denominator. Just like this. Okay, now you got to be careful with this. So in your mind, you're thinking this. In your mind, you're thinking, well, if you're not careful, this is what you're going to say. You're going to say, well, that's going to be the log of x squared minus, I'm going to change this to a product. Yes, you are going to use a product rule here because you're taking the log of a product. So that's going to become, and this is your mistake. I'm going to write out what you're probably thinking. You're thinking, well, that's going to be the log of y squared plus the log of z. And you're going to leave your answer like that. You're not going to do anything else to that except move these 2's out in front. The problem is that it's not correct. This is your error right here. Now, see, you're subtracting this log. So when you expand this, you're subtracting the log of y squared and you're subtracting the log of z. So again, let me repeat this. You're subtracting the log of y squared and you're subtracting the log of z. So right here, if you're not careful, I'm going to tell you how to fix this, but if you're not careful, you're subtracting the log of y squared and adding the log of z. This should be subtract the log of z. So going back to the first week of school when we talked about rational equations and we put parentheses around the numerator, you're going to do the same thing here. Whenever you subtract, we put parentheses around the numerator. Do the same thing here. So put parentheses here. So when you expand this, put this in parentheses. Now, it was not needed here. You might say, well, why didn't I use it here? Well, because this was just a positive 1 here. So that's not going to matter anything. Here, you're actually subtracting. So it does matter. So it does matter. So now you're going to distribute. You're going to multiply each of these by a -1, or you're going to add the opposite. Same idea. So this becomes log of x squared, and negative, we think of this -1, or add the opposite, this becomes minus log of y squared, and then minus log of z. Remember, each of these has base 10, but don't write the base 10. the symbol is just log. Now I'm going to use the power rule. So now I'm going to use the power rule. So I'm going to use the power rule only in these two. So that because this is just a 1 right here. So that becomes 2 log of x minus 2 log of y minus the log of z. And so that's your answer. Right. So when you're subtracting a log, you got to be, when you're subtracting the log of a product and you expand, you need to put this in parentheses. Otherwise, you're going to mess up because you really are saying, I'm subtracting the log of y squared and I'm subtracting the log of z. I'm subtracting the log of y squared and I'm subtracting the log of z. And that's what you see here. Okay, so be careful with numbers, with something like number 7. Okay, number 8. Suppose we had the natural log. Well, actually, let's do this. Suppose we had the log of 6x to the 9th power. The log of 6x to the 9th power. Now, remember when we did something like if I can find it. Let's see. Okay, so something like this, for example, we did the first one. So remember, here we had to use the product rule first because I couldn't use a power rule first. I can't say 10 times this because in order to do that, this whole argument has to be raised to the 10th power, and it's not. Only the y is. And the same thing for 2. I can't pull this 2 out in front first. All right, so I had to use a product rule first. Okay, now look at this one. So here, this whole argument now is being raised to 9th power. So in this case, I need to use the product rule first. That's what I need to use. So I need to use the product rule first. So it becomes 9 log of 6x. Okay? And now if I use a product rule, now again, you've got to be careful because when you expand this, you're saying the log of 6 and the log of plus the log of x. But all that is being multiplied by 9. That's what this means. So you have to be careful as well. So just like you were careful when you subtracted in number 7, right here, you got to be careful with this one. So if you're not careful, you're going to say this is, I'm going to leave a step here. You're going to say this is 9 log of 6 plus the log of x, and that's incorrect. That's not correct. So if you're going to make that mistake, if you know you're going to make that mistake, or if you're not going to be careful, what you might want to do is actually do what we did in number 7. In number 7, we use parentheses. So let's use parentheses here. Do the same thing. So what I mean is this. I'm going to say 9 times the log of 6x. And so when I expand the log of 6x, this becomes 9 times, look at this, 9 times the log of 6 plus the log of x. And then I distribute, and I get this right here. Oops, I'm going to get this right here. So I'll get it's 9 log 6 plus 9 log x. Okay? So be careful. So the answer was not 9 log 6 plus log x because you got to multiply both of these terms. When you expand, both of those terms will be multiplied by 9. And that's it. That's all you do. You're done with this. Okay, number 9. Suppose we had the natural log of 7e to the 8th power. So the natural log of 7e to the 8th power. Okay. Now, again, we're gonna use the power rule first. So that's become 8 natural log of 7e, and then I'm going to expand this right here as a sum. But both of those terms, when I expand as a sum, both of those terms have to multiply by 8. So what you might want to do is rewrite it like this first. So the natural log of 7e, kind of do that. And so then let's expand this. So this becomes 8 times the natural log of 7 plus the natural log of e. And now distribute. So you got to distribute now. So that becomes 8 natural log of 7 plus 8 natural log of e. Okay, now you got to remember something about our symbol ln, the natural log symbol. Because remember, the natural log symbol is understood to be log with base e. So that symbol is this. So these two symbols mean the same thing, except this is the one you got to write. So don't write anything in your final answer being log base e. You have to recognize that log base e is the symbol ln. Okay? So what I want you to look at is this here right now, the natural log of v. So the question is, can I simplify the natural log of v? Well, we talked about this in the last lesson. So remember what we said in the last lesson. So we said that ln is log base e, and the argument here is the argument here, okay? And so I want to know, what is this exponent equal to? So I'm going to change this log equation to an exponential. So e to what exponent is the argument e. The c is the c. Well, since the bases are the same, the exponents have to equal. So this box has to equal 1. So this is 1. And so this right here is 1. Right here. This right here is 1. So remember, I'm multiplying 8 times the ln of e times the natural log of e. So that's 8 times 1, which is just 8. So the answer is going to be 8 natural log of 7 plus 8. And so that's your answer. Okay, you got to leave your answer like this. Don't factor out the 8. You leave it like this. That's how you want to write it. Okay, number 10. Number 10. Suppose you had this. All right, suppose you had the natural log of e divided by x raised to the 5th power. Okay, e divided by x raised to the 5th power. Okay, well, just like before, you're going to use a power rule first. So I'm going to say 5 times the natural log of e. Oops, let's make this. I didn't mean to do this. Let's make this the natural log of, I'm going to change this. Sorry, 10. So that's the natural log of e divided by y to the 7th power. Let's do that. Okay, so I'm going to bring the 7 out in front. So I'm going to get 7 times the natural log of e divided by y. And now I'm going to use the quotient rule. Now, just like before, just like when we did these, we're going to put those in parentheses. Because remember, the quotient rule, you're going to subtract. You can say the natural log of the numerator, subtract the natural log of the denominator. But both of those have to be multiplied by 7. So what you may want to do is say 7 times, and they'll use the quotient rule. It's the natural log of e minus the natural log of y. Okay? And then distribute. So it becomes 7 natural log of e minus 7 natural log of y. And remember, the natural log of e, we just found, that's just 1. So 7 times 1 is 7. So I got 7 minus 7 natural log of y. Okay? All right, now I want to go back to number 8 and 9, or just one of those. Let's just look at number 8 for right now. I'm going to redo number 8. I'm going to write the problem again for number 8. So remember, number 8 was this. This is number 8. And we had the log of 6x to the 9th power. Okay? All right, now remember we said that we're going to use the power rule first. Okay, so there might be some of you that may say, well, isn't this product raised to a power, the same thing as taking each factor and raising that power? In other words, is this right here the same thing as saying 6 to the 9th times x to the 9th? And the answer is yes, it is. It is the same thing. So then you may say, well, if that's the case, then couldn't I rewrite this right here, this argument, as 6 to the 9th times x to the 9th? And the answer is yes again, you can. You can rewrite this as this. And then you may say, well, okay, so if I rewrite it like this, then couldn't I use a product rule first? Yes, you can. You can use a product rule first. So this becomes log of 6 to the 9th plus the log of x to the 9th. And then you may say, well, now I can use the power rule. And the answer is yes, you can. So take the power, pull out in front as a product, rise a product, and you get 9 log of 6 plus 9 log of x, which is what you had here. Okay? So whenever you have a product like this raised to a power, you can, if you want to, take each factor, raise it to power, and then use the product rule first. But I would suggest that you use the power rule first and then expand it. Okay? It doesn't matter. You can do it whatever way you want to, but remember this only applies, I'm sorry, right here, this raising 6 to the 9th power and raising x to the 9th power, that's only mathematically correct if this is a product. So 6 times x, that's a product, and then since that's a product, then yes, you can raise each factor to that exponent. All right. The same idea with number 10, that quotient. You could have done the same thing. Number 10, watch. You could have said, let me write number 10. Number 10 was this. You have the natural log of e divided by y raised to the 7th. So if you wanted to, you could have raised the numerator to the 7th power and raised the denominator to the 7th power. Mathematically, there's nothing wrong with that. That's mathematically correct. In other words, this becomes this. And then you can use a quotient rule. So according to quotient rule, that would be the natural log of e to the 7th minus the natural log of y to the 7th. And then you could use the power rule. So pull the powers out in front, rise a product. And so that becomes 7 natural log of e minus 7 natural log of y. And then all you got to do now is simplify the natural log of e without using a calculator. And so the natural log of e is 1. And so 7 times 1 is 7. So you get 7 minus 7 natural log of y, which is what you had if you had used the power rule first. You would have gotten the same answer. Okay? All right, so that's going to take care of this part of the lesson.